Hello and welcome to Earthquake Tips. My name is Dr. Shailesh Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, BMTPC. Through these tips, our aim is to spread right technical information in simple to understand language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. Before we start, let's make a pledge that any new structure we construct or build must be earthquake resistant. The first earthquake tip will elaborate on what causes earthquakes. The most scientific theory behind earthquake occurrence is plate tectonics theory. And for that, we need to first understand the structure of our Mother Earth, particularly its interior. This figure shows that Earth is divided into different layers. The innermost layer is inner core, then outer core, mantle, and outermost layer is called crust, which has thickness varying from 5 to 40 kilometers. Over the crust, what we have is land or soil. The inner core is solid, comprising of heavy metals like copper, nickel, whereas the crust is of lighter materials, namely basalt, granite rocks. Also, the inner core is solid, whereas outer core mantle are in liquid form having ability to flow. The temperature at the core is approximately 2500 degrees Celsius, whereas the surface of Earth, that is top of crust, it is around 25 degrees Celsius. Also, there is huge difference in atmospheric pressure as we move from inner core to crust. Because of this high temperature and pressure difference between core and crust, the convection currents develop in the mantle, which is in liquid form. Remember, boiling of water in a kettle, it happens due to convective flow. So the mantle, which is in liquid form, the convection current develops there, and this results in circulation of earth mass, that is hot molten lava comes out, and rock mass, which is cold, goes inside. Many such local circulation takes place in different regions of the Earth's surface, leading to constant movement of different portions of the Earth in different directions along the surface. Means because of this convection flow, hot molten lava comes out, cold rock mass goes inside, and these kind of circulations, local circulations in different regions of the Earth continue to take place. Because of this convective flow of mantle material, some portion of the mantle slide on outer core. This sliding of earth mass takes place in pieces called tectonic plates. There are 7 major tectonic plates the earth's surface is divided into, and there are many smaller ones. These tectonic plates move in different directions and at different speeds from those of neighboring tectonic plates. This figure shows the 7 tectonic plates, major tectonic plates which we have. Now, if we look at the interaction between the plates, sometimes when the plate in front is slower, then the plate behind it comes and collide. It is called convergent boundary. So these convergent boundaries result in mountain formation. When plates move away from each other, it is called divergent boundary, and rifts are formed. Sometimes plate move side by side. This kind of boundary is called transform boundary, and this side by side interaction can be in the same direction or it can be in opposite direction. These relative movements of plates are interplate movements and can be of the order of couple of tens of centimeter per year on an average. Now let's see how earthquakes generate. These rocks or tectonic plates, which I just mentioned, are made of elastic material. And so elastic energy, strain energy, is stored in them during the movement of these dendritic plates. These elastic energy keeps building up until the rock along a weak region in the earth crust reach their strength, giving way to sudden movement, releasing the earth. This weak portion uh, is called fault, and the opposite sides of the fault, which is a crack in the rock where this movement takes place, suddenly slip and release large elastic energy stored in the interface rock. This sudden slip at the fault causes earthquake, which is violent shaking of earth when large strain energy released spreads out through seismic waves that travel through the body and along the surface of the earth. After the earthquake is over, the process of strain buildup at this modified interface between the rocks starts all over again. This is called elastic rebound theory, which is attributed to earthquake generation. So, as you can see in this figure, elastic energy builds up, release at the weaker section through sudden slip at the fault. The fault is the crack in the tectonic plate or rock, and then again buildup starts taking place, and then again it gets released and through a sudden slip at the fault. Do you know these faults often run into tens of kilometers and constitute an oblong 3D volume? Imagine sudden slip of such voluminous rock. Do you know energy released during 2001 Bhuj earthquake was about 400 times the energy released by 1945 atom bomb drop on Hiroshima. So this was all about what causes earthquakes. But before we end, let's have a look on types of earthquakes and faults. Most earthquakes in the world occur along the boundary of tectonic plates. Remember, I told you interplate earthquakes. These earthquakes which happens along the boundary of tectonic plates are called interplate earthquakes. For example, in the 1897 Assam India earthquake was interplate earthquake. Number of earthquakes also occur within the plate, within the tectonic plate itself, away from plate boundaries. These are called intraplate earthquakes. For example, 1993 Latur, India earthquake was intraplate earthquakes. Now, during both types of earthquakes, the sudden slip at the fault uh, takes place, and this slip can either be in horizontal direction or it can be in vertical direction. When it is in horizontal and vertical direction, these kind of slip at faults is known as D-slip faults. And when this slip occurs in lateral direction, then it is called strike slip faults. And one of them, either horizontal or vertical direction or a lateral direction, dominates during earthquakes. So this was all about what causes earthquakes and types of earthquakes. I hope the earthquake tip number 1 is useful for you. If you want to download the tip, you can access it from www.bmtpc.org website. Thank you and see you for the next earthquake tip.